Hello everyone, this is the third video of influence line diagram. In the previous video we have seen how to draw influence line diagram for different force responses like support reaction for RA. We have seen how to draw influence line diagram for RA. For example, if you have a simply supported beam A, this is B, and you take any point C between A and B and define the distance A. So in the influence line diagram video number 2, we have seen how to draw influence line diagram for RA, okay, ILD for RA. We have also seen how to draw ILD for shear force at C and ILD for bending moment at C. So I will just draw what we have studied in the previous video. For RA, ILD influence line diagram is like this. One at A it is one unity, here it is 0, A, B. Influence line diagram for shear force at C is like this. Straight line. So here this is negative shear force and this is positive shear force. This is A by L and this will be L minus A by L. You know L and you also know A. For bending moment, ILD is positive. AB by L. B is the distance of C from B. Small b is the distance of C from capital B. So these are the influence line diagram we have to use when we go to solve the problems. And after this we will see what are the different types of load that are coming on a bridge, on a simply supported bridge, and how we can use this influence line diagram, that we will see. So here we have a different moving loads which are moving on the bridge. You have a single point load, I can name it as W. You can also have UDL. Intensity of UDL is kilonewton per meter, which can be longer than the span. You also have UDL, which can be shorter than the span, and multiple loads, okay, or a train of point loads. So these are the different loads you have. First we will see how we can take this single point load into the analysis. When this single point load is moving, how can we calculate maximum RA, where we have to place this load so as to calculate maximum RA, where we have to place this load so as to calculate maximum shear force at C and maximum bending moment at C. So we have drawn the influence line diagram here, and now we will see how the single point load is influencing factor, and how this RA, shear force at C and MC at C is getting influenced. Now you see the load is moving, the single point load is moving, W, from left to right. Distance is x from A, okay. So our aim is to find maximum responses, maximum RA maximum shear force at C, maximum bending moment at C. So where we have to place this load so as to calculate maximum RA. For that you have to draw influence line diagram for RA. This diagram is influence line diagram for RA. Okay, and where we have to place the load, you see from the diagram it is clear that the maximum ordinate is at A. The ordinate at A is 1, and as you go to B it is decreasing. So where you have maximum ordinate, at that point you have to place the load so as to get maximum RA. And how can we calculate RA here? RA equals to directly W into 1, because here ordinate is 1. If you go to calculate here, if you place the load here, for example the load is moving, this ordinate will be less than 1. Here you may get 0.8, 0.7, 0.6, 0.5, 0. So when you place load here at this point, reaction will be, for example, W into 0.8. So here you will get 0.8 W, and here you will get W. So where you are getting maximum RA? When you are placing W single point load at A, then you are getting maximum RA. Okay, now we have to talk about shear force at C. Okay, so we are dealing with a single point load which is moving from A to B. Our aim is to calculate maximum shear force at C. So where we have to place this single point load so as to get maximum shear force at C. Okay, so for that you have to draw the influence line diagram. When you draw influence line diagram for shear force at C, you are getting negative influence line diagram and positive influence line diagram. Here you are having maximum negative ordinate, okay, and here you are having maximum positive ordinate. So you are getting positive shear force at C. We have to calculate maximum positive shear force at C and maximum negative shear force at C. Both thing we have to calculate maximum. So where you are having maximum positive ordinate for shear force at C, if you look at the diagram, this part of the diagram is positive shear force, positive influence line diagram. Okay, and where you have maximum? Here at this point. So you have to place load here. Okay, so how can you calculate shear force at C? Maximum positive shear force at C, load into ordinate, W into L minus A divided by L. So this is maximum shear force at C. And how can you calculate negative shear force at C? Maximum negative shear force at C? You have to place the load at the same point, because here at the same point you are having maximum negative ordinate. So I can write here minus W into A by L. So this is maximum positive shear force at C. This is maximum negative shear force at C. So in this way we have to place the load so as to calculate maximum shear force at C, positive and negative. Again you see we have the same load, single point load W, which is moving from A to B. Here our purpose is to find maximum bending moment to this moving load, to this single point load which is moving from A to B. Okay, so how can we calculate maximum moment at C? For that we have to draw the influence line diagram for bending moment at C. Okay, so we have to draw this. I will show the diagram here. Simply supported beam. At this point you have to draw influence line diagram for bending moment. From A to C you have A, small a. From C to B you have small b. So influence line diagram for bending moment is this, and the maximum ordinate, or you can say this height, is AB by L. So where we have to place the load? It is very apparent from the figure that we have to place load at this point. Why? Because at this point we are getting maximum ordinate. Okay, so how can we calculate bending moment at C? Bending moment at C, maximum, I will write maximum here. Okay, point load, single point load into ordinates AB by L. So in this way we can calculate maximum responses by putting single point load at the appropriate position. We have to see where you have maximum ordinate. At that point we have to place the single point load. Okay, so now we will deal with we have done with the single point load. We will deal with UDL longer than the span. After that UDL shorter than the span, and multiple loads or a train of multiple point loads.